Today we'll talk about the decision tree, and I referred from the machine learning lecture of KAIST. And okay, before diving into decision tree, what is machine learning? We can express that a computer programming is said that learn from experience E, and with respect to some of class of task T and performance measure P. If its performance at task in T and it's measured by P, improved with experience E. It's a very abstract explanation of machine learning, and as you know, you already are familiar with machine learning. Okay. And next, we can imagine that a perfect world for rule-based learning. Imagine a perfect world with no observation errors, no inconstant observations. In this case, the training data is error-free, noise-free, and no stochastic elements in the system we observe. In this case, the target function is deterministic. The target function is the formula which explain the hypothesis. Okay, and next, the full information in the observations to regenerate the system. The target function is contained in hypothesis set. Yes. Okay, the observation, well, we can imagine the example of the whether to enjoy or not by the weather condition. Okay, so we can observation of the people by the features sky, temp, humid, wind, water, forecast, and we can expect the result of enjoy. And this is the example table, and continue it. And in this case, the function what is the function approximation? Machine learning is relative to applying function approximation well. Machine learning. What is machine learning? As I mentioned, the effort of producing a better approximate function. Our objective is approximate well. Okay, in the perfect world of enjoy sport, in this case, the instance X is the feature and the label, and the feature is in this table sunny, warm, normal, strong, warm, same, and the sunny is the feature of sky, warm is temp, normal is humid, and okay, and the label is the result of enjoy or not. In this case, enjoy yes. And next, what is the training data set D? A collection training data set D is a collection of observations on the instance, and this is the collection of x's. And hypothesis H is a potentially possible function to turn x into y. In this case, y is the label x, and the instance x is a feature exactly. So our hypothesis is turn h to turn x to y. Okay, so hi is sunny, warm, question mark, and same. In this case, we can this x into y at yes. And next, the target function C is an unknown target function between the features and the label. So our objective is expressing hypothesis H to target function C. Okay. In graphical representation of a function approximation, we can express the instance X as this space and hypothesis H in this space, and we can mapping the instance X to hypothesis H, and in each instance has a relations from more general to more specific, and as mapping it, the hypothesis also has a more general to more specific. Okay, so in this case, this hypothesis H1 is more general, and H3 is more specific. For example, the X1 is the sunny, warm, normal, strong, warm, same, and the H1 is sunny and question, warm, question. In this case, the main element of the feature is sunny and warm. But in the case of instance X3, the hypothesis H3 is sunny, strong, warm. It becomes more specific. So what would be better function approximation in this case? So we will talk about next class. Okay, thank you.